There are going to be times when we want to enter data into SPSS that's been accumulated into tables, such as the one that we have here that we created in a previous video. For instance, in this table, we have a certain exposure, like which country that a person is living in that contracts Ebola, whether they're living in Guinea or Liberia. In another data set, this might be male and female for gender and so on and so forth. And the outcome that we have in this contingency table is whether or not they died or whether they survived that case of Ebola. So in Guinea, we have 1,214 people who died out of a total of 2,047 cases. We have in Liberia 2,963 people who died out of a total of 7,082 cases. This data was gathered from the file that we had on Ebola cases. Okay, in some cases, you might be interested in comparing Guinea. And again, this number would be derived from the total, the 833. You'd subtract the number of people that died from the total number of people that had the cases, presuming that then lost track of people, so on and so forth. There weren't current cases and stuff. A little bit more complicated than I'm making it here. And you might want to compare that instead of to a single other country, the rate overall for all countries, for instance, or the rate for all other countries, not counting Guinea, in order to get a relative risk odds ratio for the rate of mortality in those countries. So, for instance, if this were, let's say, total number of cases, this was 2047. Let's say that this turned out to be 10,000 cases, and of those 10,000 cases, 2,000 of them died. And you would have that data by adding up all those numbers for the different countries on the last day that you have data for. So that would leave 8,000 people that didn't die. So the odds of dying if you were in Guinea is 1214 over 833. Or you could also look at that as the risk as we did before and so on and so forth. I'm just going to leave this as odds. Right? And this would be 2,000. Oops. Over 8,000. The only problem with this is then we can compare these to see whether the risk is higher or the odds are higher in Guinea, all the other countries combined, and get an idea of whether there's an unusually higher risk of mortality in Guinea. Now, the problem is that we could also do this relative risk, but in Excel, it's not going to be a trivial matter to calculate the odds ratio to tell if this result is really significant, if the odds ratio for this comparison, in other words, this odds ratio, whether that's really significantly less different than 1, or whether that difference from 1 is really just due to chance, or could be due to chance. Okay, so let's say we want to go ahead and get this, oops, something going on in the background there while I'm talking. Let's say that I get this into, I want to get this imported, this information imported into Excel. Excel normally would prefer to work with, like in this case, each of the 9,129 cases listed as rows in an SPSS document. So it's a little bit different than native data that we would normally work with in SPSS. So how are we going to import this? Well, I'm going to bring up an SPSS file. I just opened a new data file, okay, completely new data file. And I'm going to go into the variable view. Okay, what I'm going to do is I'm going to create the variables that I need to work with this. Okay, the first variable that I'm going to make is going to be the country. Okay, so in our case, it's Guinea and Liberia. And the second variable that I'm going to make is going to be, I'm going to call it mortality, whether a person died or lived. Okay, and both of these variables, since it's a contingency table that I'm working on, both of these variables are going to be nominal variables. Okay, so the country, I'm going to go ahead and put values in here for the country. I'm going to make 1 Guinea, I'm going to make 2 Liberia. Okay, and for the mortality, I'm going to make 1 died, the outcome that they died, and 2, the outcome that they lived. And I'm going to say OK. Now, if I go back and take a look at that in the data view, I don't have any data in there yet, but I'm about to get to that. And we'll take a look at what that looks like. So let's see what our possibility. I'm going to make a third variable. And that third variable, which kind of ties in to our tables, is I'm going to put in frequency. And frequency is going to be a numeric variable. And this time, whoops, I get rid of these two. I don't need them. Accidentally spread that out a little bit. Okay, frequency is going to be a scalar variable, a numeric variable. Okay, and I'm going to go back here to my data view. And now I have 3 variables, the 2 that I have in my table, the country, and the mortality, whether they died or whether they lived. But I also have a third variable called frequency, which is going to represent each one of these numbers. So let's take a look at what all the possibilities are. For Guinea, I have people that died and I have people that lived. So I'm going to go back here and I'm going to say died, which is a country. I'm going to say Guinea, which is 1. But I have 2 possibilities for Guinea. So I'm going to make a second row for Guinea. In one case, the victims died, or in the other case, they lived. 2. I put 2 in there. So 1 and 1 for Guinea, 1 and 2 for mortality. So I have all the possibilities for Guinea, whether they died or they lived, which column that they were in. Now I'm going to do the same thing for Liberia, except Liberia, I said, was 2. And similarly for Liberia, you have some people that lived, put a 1 in, and some people that died, I'll put a 2 in, died, and some people 2 that lived. I put 1 as the condition died because I want that in the left column, and that's the way SPSS is going to organize it. Okay, so I'm going to go back here and look at the frequencies here. So for died in Guinea, we have 1,214. So for died in Guinea, I'm going to put 1,214. 1,214 people. For Guinea, the number of people that lived, I'm going to put 833. For Liberia, I'm going to put 2,963, representing the number of people that died in Liberia. And for the number of people that lived in Liberia or survived in Liberia, I'm going to put 4,119. Oops. Okay, and you could literally take another table or repeat this for Guinea and all other countries. Instead of Liberia, you would have a variable, or you would have all other countries in here. Okay, and you'd calculate the number of people that died or lived in Guinea versus the number of people that died and lived in all other countries, or maybe all other countries excluding Guinea. In other words, every other country, rather than all countries together. Just the countries that are other than Guinea, see if the rate is different. But you can make that judgment as to how you might want to do that. Okay, so for right now, I'm just comparing Guinea and Liberia to see whether the mortality rates in Guinea were higher than they were in Liberia. So now SPSS, kind of unusual to see this kind of data in SPSS. And the way that we deal with this, in order to tell SPSS, well, this is not really 4 cases that we're looking at, case number 1, case number 2, case number 3, like individuals who, say, lived in Guinea and so on and so forth, or died or had a certain temperature or something like that. This is not an individual. This actually represents that number of cases. Okay, so how am I going to translate that for SPSS? Well, the way I'm going to do that is I'm going to go use this scale over here, which is called weighting. In other words, I'm going to weight the cases for the frequencies. I'm going to click on that, and I'm going to tell SPSS that I want it to weight the cases. In other words, convert that into a number of cases, but for the variable frequency, using the variable frequency. I'm going to move that in there. I'm going to click OK. Okay, so not too much appears to have changed here. Output table came up momentarily. Not too much appears to have changed for us here. But in fact, now SPSS is looking at this no longer as 4 cases, but as the total number of cases added up for all of these different countries, like something like, I guess, 9,000 cases or something like that. And I'll see that when I do the analysis. Let's analyze. Descriptive statistics, crosstabs, and I'm going to say, well, the exposure is the country that the people were living in, and the outcome is the mortality, whether or not they lived or died. Okay, so I'm going to go ahead and ask it to display that as observed values, and I'm going to ask it while I'm here to calculate percentages by rows. I'm going to click OK. And you'll see that SPSS figured out that this is the kind of table that I'm talking about and actually calculated the percentages. Mortality or the risk was 59% and 41.8%, so on and so forth. Relative risk would be 59% divided by 41%. And the odds would be 12, 14, and so on and so forth. Let's actually get SPSS to calculate all those for us. I'm going to go into descriptive statistics, crosstabs. I'm going to ask it to tell me, let's see, calculate chi-square for this 2x2 table, and go ahead and calculate the risks and the confidence. The risks, meaning the relative risk and the odds ratio for me, and calculate at the same time for me the confidence intervals for those numbers. I'm going to click continue and say OK. And sure enough, SPSS goes ahead and calculates chi-square for me, which is significant, as we can see, because the probability of being wrong if I reject my null hypothesis, that there's no association between the country you live in and the mortality rate, is less than 0.001. So that's statistically significant. And it calculates a odds ratio and a relative risk for me. The relative risk is 1.41, the second line. Okay, you're 1.41 times as likely, as we saw when we calculated it before, 1 times as likely to die in Guinea if you contract Ebola than you were in Liberia. And the odds ratio, well, the odds are 2 times as likely that you'll die if you contract Ebola in Guinea versus Liberia. And the confidence interval for the odds ratio is 1.8 to 2.2. So we see that 1 is excluded from that odds ratio, from that confidence interval for the odds ratio. So we're 95% certain that the odds of dying are not for Guinea versus Liberia exclude the value 1, which would suggest that there's no association between the country you lived in, Guinea, and versus Liberia. So we can say that our results for odds ratio are statistically significant. Okay, and reject our null hypothesis that the odds ratio is equal to 1 for these countries. So that's one of the ways that you might want to work with this, so that you can take advantage of SPSS. That weighting function allows you to tell SPSS to see this as 9,000 cases instead of seeing this as 4 cases. But the real key here is to recognize that you want to make sure that SPSS understands that there are 4 possibilities in this crosstabs. You live in Guinea and you died. You live in Guinea and you lived in Liberia and died, and you lived in Liberia and you lived. So hopefully that'll help you assemble other tables using this data, or use this particular analysis, or compare countries to countries of interest to other countries of interest, and so on and so forth. So hopefully this will help you take this method and apply it to other parts of this data. For instance, one of the things that I might be most interested in is the rate for a particular country versus all the other countries combined, or a particular country versus all the other countries, excluding the country that you're examining, and so on and so forth to see if, and you might want to do that for a couple of specific countries, or you might want to do it for all of the countries to see how they compare to the overall rate of mortality for all the cases of Ebola. But hopefully that'll help you do that. Email me if you have questions about this technique, and hopefully I might be able to help you with it a bit more. Okay, good luck. Bye.